Okay, x equals 0, and why is that?
Well, you can't divide by 0.
Right, you can't have a 0 in the denominator, and if that x was a 0, then my denominator would be 0. Okay, on the second one, I've got to figure out what would make that denominator 0, and in order to do that, I'm probably going to need to... That's one of the answers.
Yeah,
But there's actually two things that would make that 0. So to figure out what would make this come out to be 0, let's solve that. So what type of factoring would you have to use to solve that?
you could do just common factoring.
Yeah, common factoring. Pull a 2 and an x out. If I pull a 2 and an x out, what am I left with?
3x plus 2. So 2/3.
So the only two numbers that would make this denominator come out to be a 0. Close, 0 and negative 2/3. So 0 and negative 2/3 are my excluded values. Okay?
You can get to 2.5 a day.
Does that make sense? All right, so number 3 wants you to list the excluded values, but they also want you to simplify it. Okay? So to do that, we're going to need to do a lot of factoring.
I'm going to do top of all of
Doesn't really matter which one we do first. We're going to do both.
That's the top.
So,
Just needs
that's,
factored.
yeah, the top one we can trinomial factor, and we don't even need a box. So we would need z times z, right?
Yeah, 3 and 1.
I wish you guys could just use x for all of them. 'Cause I never had to.
Possible. Sorry, they don't always just use x. It's okay if you use x in your notes. It doesn't really matter.
Yeah, can you put X in
If you want to change them to x's, yeah. So now I need to factor a z out of the denominator, common factor out of z, and what will I be left with?
Z squared minus 2z minus 3.
So my top part is factor as much as I can go, but that denominator will factor some more. If I trinomial factor that denominator, once again, I don't need a box. What will multiply to give me negative 3, but add to give me negative 2?
Negative 3 and 1.
Negative 3 times positive 1. Now, don't go to canceling yet. We want to do our excluded values first because your excluded values are based off the original problem. So what will I get for excluded values based on this denominator? What would make any of these turn out to be a 0?
0, 3, negative.
Okay, a 0,
3.
a positive 3, and a negative 1. 0, 3, and negative 1. Those are my 3 excluded values. Now, they also asked me to simplify. So to simplify this as much as possible, I'm going to cancel out the z plus 1s because they're exactly the same quantity. So then my answer is what's left. Z plus 3 over z times z minus 3. So that's going to be my answer. Now, if you happen to do distributive property in that denominator, it should accept it either way. So if you type in z plus 3 over z squared minus 3z, that should also be acceptable. So in other words, I just multiplied that through there.
Yeah.
Okay, does that make sense? Everybody good with number 3? All right. Number 4. Number 4 wants us to also give the excluded values and to simplify. The excluded value isn't bad because there's only one thing in the denominator. We can get that right off the bat. So what would my
So
excluded value
5
be?
thirds.
I can't get this thing to scroll. There we go.
On the bottom would be 5 thirds.
Okay, so a 5/3 would make my denominator come out 0, right? So x cannot be 5/3.
And simplify that. The bottom simplified, right?
The bottom is simplified, but the numerator, and notice I gave you a hint. Recall from our previous lesson, this is the formula for the difference of
5,
2 cubes.
3, right?
The cube root of this is 5, and the
3.
cube root of that's 3x.
Yeah.
So you may want to rewrite this as a 3x cubed minus a 5 cubed.
Over 3x.
My a is going to be a 3x, and my b is going to be a 5, correct? Remember, those are never negative. And so now I'm going to use this formula. I'm going to transform from this format to this format. Everywhere I see an A, I'm going to put a 3x. Everywhere I see a B, I'm going to put a 5. So if I do that, what will I get for A minus B?
3x minus 5.
Yeah, my A is a 3x and my B is a 5. So 3x minus 5. Okay. I need to now...
9x squared.
Yeah, good. 9x squared. What's the most common mistake I see there?
You know, square root of 3
All right, a lot of people put 3x squared there instead of 9x because it's 3x times 3x. Plus, right? Opposite sign. A times B. So 3x times 5 would be 15x. And
plus
B squared,
25.
25. Okay, so now these quantities will cancel. And remember, the instructions were to simplify, so most people look at this and they think they need to factor it. But if you remember me telling you yesterday, anytime you do sum or difference of
At
cubes,
this time, please release JV and varsity volleyball players going to Central Heights.
this will never, ever factor. Okay? Anytime you do sum or difference of cubes, this thing never breaks down. You would have to use, if you were solving, you could use the quadratic formula, but I'm not trying to find out what x is here. I'm not solving it. I'm just simplifying. So that is as simplified as you can get it. That is your answer. Okay? All right. Number 5. So number 5, I am multiplying two fractions together. So to multiply them together, I'm going to want to simplify as much as possible. What are my excluded values? They're pretty easy to see right off the bat. Y can never be a 2 or a 6. Okay, now the bottom's already factored. This one's easy to factor without a box. That one I'm going to need a box. So let's see if I rewrite this thing. My numerator will both look like that. I have a y minus 2 here, a y minus 6 here. So this one factors easily. Negative 9 times negative 2 will give you 18 and add to give you negative 11. So y minus 9 and y minus 2, right? Okay. This one we're probably going to want to use a box for. So I have a 2y squared here and a negative 18 here. That's my first and last term. If I multiply them together, what do I get? Negative 36. So I need two things that will multiply to give me 36, but add to give me negative 9. Multiply to give me 36. So that could be 3 and 12 would work. If I put a negative on the 12, right? Yep. Negative 12y and a positive 3y. That will give you a negative 9. So what do these two have in common?
Y.
Okay. And what times y will give you 2y squared?
2y.
And what times y will give you 3y?
3.
And what times 2y will give you negative 12y? Okay, so now we have a 2y plus 3 and a y minus 6.
Now you can start canceling
Cancel now.
the 2y, negative y minus
Y minus 2, that's an entire quantity. And if this was a plus sign here, I couldn't do that. But since it's multiplication, I can.
What about negative 6?
Yeah.
The y minus 6's will cancel as well. And so now I'm left with,
2y plus 3, y minus 9.
so you can write your answer like this. You can write your answer just like this, or you can actually work it out. It'll take it either way. But why do more work than you need to, right? So I would just put the answer in like that. Okay, does that make sense? Yeah, I'm sure you did. You definitely did this
Except for
last
the
year.
a minus.
Yeah.
Yeah, you probably didn't do sum and difference of cubes necessarily.
Do that, but we did.
All right, are we ready for 6?
Yeah. Actually, I have room to work now. We were just kind of on that page.
Yeah, that was terrible.
this the same? Is it the same numbers we just had?
Yeah. Kind
No.
It is on that one first.
Close. Yeah.
Just opposite.
It's negative.
Oh, it's the same thing actually.
Okay, so on this one, number 6, you're dividing a fraction. So let's review from 6th grade how you divide fractions. So let's say you guys have this 5, 6. If you were to have 5, 6 divided by 7 twelfths.
of. Cross multiply.
Nope.
I just think.
Anybody know how to do that?
So when you just,
You flip this one over and change it to multiplication.
That's
Oh.
basically what I
Right?
said.
Change it to
But
multiplication,
Do you
flip
want
it
to
over.
flip that one yet?
Yeah. 5, 6 times 12 sevenths. If you flip it, then you can reduce these, and then you end up with 10 sevenths as your answer.
Okay.
Does that make
Yes, it
sense?
does.
Okay, so we're going to follow through on that same procedure over here. I have division, so I'm going to flip this one over and change this to multiplication. So we have y squared minus 11y plus 18 all over y plus 8. Flip it over, and I have a y plus 8 over y squared plus 7y minus 18.
But when you start factoring, you're gonna get
Y minus 2, Y minus 9 on top.
Can I go ahead and cancel these?
Yeah.
I've got multiplication between them. All right, I can cancel that whole quantity with that. And so now I'm left with y squared minus 11y plus 18. Over y squared plus 7y minus 18. Now we can do that factor thing you were talking about, Hunter.
Yeah.
So if I factor that numerator, I'm looking for something that will multiply to give me 18 but add to give me negative 11.
Then it's -9 and -2.
Yeah, and then the bottom one's gonna be 9 and negative 2.
The whole thing's gonna be y minus 9 over y plus 9.
So the bottom one you said factors to
9 and -2.
positive 9 and negative 2.
Yeah.
Okay. All right, so now if you cancel the y minus 2's, the entire quantities are you're left with, as an answer, y minus 9 over y plus 9.
Do you need it? Okay, so you have to put parentheses because it's only one term.
Right.
Yes.
Correct.
Just gonna have it in
Okay. Everybody okay with number 6?
It's all right.
Okay.
there.
Okay, so 7 and 8 look complicated, and they kind of are. 7 is we call that a complex fraction. When you have a fraction within a fraction, we call that a complex fraction. And it's really not acceptable in mathematics to ever leave something as a fraction within a fraction. So there's a couple of ways to do this. We'll do each one differently. I'll show you the way I think is the easiest. So this one says multiply the top and bottom by a common denominator. So when you look at all 4 terms you have here, the only denominator you have is a y squared, right? So I'm going to take all 4 terms times y squared, because when I take this times y squared, they'll cancel and the fraction within a fraction will go away. So essentially it's going to look like this. 9y plus 36, I'm just writing the original problem down right now. 3 minus 48 over y squared. And I am going to take and multiply my numerator times y squared and my denominator. Because essentially when I do something like that, I'm just multiplying by a 1. And multiplying by 1 never changes the value of anything. That's why it's okay to do that. Okay? All right, so to take this y squared times the numerator, I'm basically going to be doing distributive property. I'm going to take this y squared times both of these. So if I take y squared times 9y, what will I get?
9y cubed.
9y cubed. Because we add the powers.
Got him there.
All right, what about y squared times 36?
36y squared.
Mm-hmm. Okay, now when I do the denominator, I've got to take y squared times 3, which would be 3y squared. And now I've got to take y squared times this. What's going to happen when I take y squared
You're
times
just
this?
going to cancel it. Seriously.
Yeah, comes out with a minus 48,
Yeah, I
right?
don't know why you had that plus.
Okay, now, I would love to say we're done, but I have to check and see if this stuff will cancel or factor, and they both do factor, So we need to do that. What can I factor out of the numerator?
The numerator, 9.
A 9, what else?
Y and Y
2.
Y squared. Okay, if I factor out a 9y squared, what am I left with?
Y plus 36y squared.
Just y plus 36,
Oh, yeah.
because we already got the y squared to the outside.
No, if you
Well,
factor
I
out
did
9,
Y
it'd be
four.
y plus 4.
Oh, you're right.
two.
A 4.
That was not me.
That's
That was
okay,
all
that's
you.
okay.
That was all you. That was
All right, so we factored out a 9y squared. On this one, what do these two have in common?
3.
Yeah.
Okay. So what am I left with if I factor out a 3?
Y squared.
16.
16. Okay, so what do you think? Am I done?
Yeah.
No.
No.
Can you drop the
You can just square root.
2, make that 2y squared?
You square root that y squared minus 16.
Okay, so I think you're thinking they have nice square roots and subtraction, so we call that difference of squares. So when you have difference of squares, what happens when you factor it?
Plus or minus.
You get a y plus 4 and a y minus 4. Remember yesterday how we talked about a squared minus b squared always equals a minus b times a plus b? Remember that?
Yeah.
Okay. Oh, I don't know why I have a 2 out there. Okay, so that being said, we're going to factor this thing one more time. My numerator is done. I can't do anything else with that.
So you're just going to put the 9y squared on top.
So these
Cancel.
cancel. What about the 3 and the 9?
Reduce.
Reduce.
Reduce those. 3 goes into 9 3 times.
3y squared.
So now I am left with 3y squared on top,
Y minus 4.
and that is your answer. Okay? Everybody good with that?
Yeah, I guess so.
All right, so number 8 is kind of a crazy one.
Yeah, I don't know about that.
That was
Looks,
See, this is
Crazy eights.
it's a crazy one.
Just, we're just,
Let's
It's
just
the-
keep
this takes too much time. This is,
It'll be fine. You're up for the challenge.
we have to work pretty much 2 problems and then do another.
Yeah, you're right. It kind of like is working
Like
2
three
problems.
problems.
So basically, we're going to work the numerator and the denominator separately using a common denominator for each. So if you look at your 2 fractions here, we probably need to go back to 6th grade a little bit and review how to add fractions. Think about if you have 1/3 plus, let's say 3/4. If you have 1/3 plus 3/4, how do you find a common denominator?
3 times 4.
12.
Right, it's 3 times 4, which is 12, all right? So then you rewrite it so that both fractions have a 12 on the bottom, okay? So if I multiplied this times a 4 to get this, I better do it to the same thing to the numerator so I don't change the value of the fraction. So 4 12s and 9 12s, okay? And notice you could have also just cross multiplied 1 times 4 gives you the 4, and the 3 times 3 gives you the 9. From this step, we would probably change it to 1 fraction. You'll see why I included that step when we do the algebraic version. Okay?
Why don't you just add them together?
I will, but for the algebra, when you get to doing it with the algebra, you're going to need this step. Okay? So I'm writing it as 1 fraction because they both, and I'm also reiterating that you do not add these numbers together, right? You just keep it in, if you have 4 12ths and 9 12ths, we're going to end up with 13 12ths. And you don't need to change it to 1 and 1/12. You can just leave it 13 12ths. Okay? All right, so now that we've reviewed that, let's go up here and add these 2 fractions together. Look at my 2 denominators. How do I find a common denominator? Multiplying by each other. So my common denominator is going to be 3y times z minus 7. So I'm going to write each fraction with a 3y times z minus 7. Okay, so what would I have to take this times to get this denominator?
Talk about the.
So it'd be
times
3y
2
on another one.
Times z minus 7.
Okay, I need to take this times z minus 7, right?
Yeah.
So 1 times z minus 7 is z minus 7.
No, this is 3y.
And then
And-
they'll cancel.
And then this one's a 3y. Well, you don't want to cancel them, because if you do, you're going to end up right back here where you are.
It's true.
Okay? Okay, then the next step, what did we do after that? This is where we are. We just did this. The next step was to write it as one fraction, right? So since my denominators are the same, I can write this as one fraction. So that would be 3yz minus 7 for my common denominator. And if I put my two numerators together, I'm going to have z minus 7 plus 3y. Does that make sense? Okay, so that's all I can do with the numerator at this point. Okay, now I'm ready to work on the denominator. So if you look at your denominator, it looks even crazier, right? So I want you to look at this denominator right here, and let's factor out what it has in common to see if this is included within this. 11z, so this could be rewritten as 11z times what? Z minus 7?
Yep.
Okay, so this 11z is included in here. So an example of that from 6th grade would be like, what if you wanted to add 1/3 and 5/6? When you found the common denominator in those two, you didn't need to multiply the two together. Why?
Because, yeah.
Because 3 is contained within 6, right? 6 is really 2 times 3. And so if this number was contained in here, you didn't have to multiply them together. You could, it just makes your numbers bigger than they need to be. Okay? So since the 3 is contained within the 6, I just say my common denominator is 6, right? And then that would mean a 2 here and nothing changed here. Correct? Okay, so let's do that with this. Since this is contained within this, this is going to be my common denominator. So my common denominator is 11z minus z, or times z minus 7 for two separate fractions. So, what did I have to multiply this times to get this? A z minus 7. So I got to take this 1 times a z minus 7. I didn't multiply this one times anything, did I? Because this is equivalent to this.
Yep.
Okay, so I just have a 3y. Bottom didn't change, neither did the top. Okay, well now that I've got a common denominator, I can go to the next step, which is to write it as one fraction. Okay, you with me? Okay, so now what I have is one big fraction divided by one big fraction. So when you have a fraction divided by a fraction, what can you do?
Flip them.
Flip them and multiply them.
Oh
So it's in a different format. Like imagine if you had this, if you had 1/6 divided by 9/12, then you could flip the 9/12 and make it a 12/9 and turn it into multiplication. Okay? So that's what we're...
Cancel them out.
Yep.
And oh my
Flip and
God,
multiply.
look at that.
Z minus 7 plus 3y all over 3y times z minus 7 is going to be multiplied times the flip of the denominator, which is 11z times z minus 7 over z minus 7 plus 3y. So all of a sudden, writing neatly becomes somewhat important.
Yep.
All right, so what cancels?
The z minus 7 plus 3y.
Okay.
It's 11z over 3y.
Oh, but you know what? This cancels too, right?
the z minus 7.
So now I have 11z over 3y, and I'm done.
Yeah, finally. That one takes forever.
For a second there, I was all pretzel brain.
It all flew together, huh? All right. That was number 8. Now I kind of tricked you because the next page,
Another number.
it's another number 8. So, I'm just trying to trick you into believing you're doing less problems than what you really are. So the second number 8, they want you to simplify by adding or subtracting fractions. Common denominators are needed, of course, when you add and subtract fractions. So look at this one. My denominators, I have no excluded values because there are no x's in the denominator, right?
Yep.
I have a 3, a 7, and a 21. What would my common denominator be?
21.
21. Okay, so I'm going to shortcut it here just a little bit. Instead of writing it as
21 plus
It deletes the 21.
12 over 21.
okay, so instead of doing this, which is what we normally would do,
Yeah.
I'm going to skip and I'm going to go right to the part where we write it as one fraction. Okay? Because that wouldn't be too hard to do.
Not too
So
crazy.
what do I need to multiply this 3 times to get my 21?
7.
So that means I got to take this times 7.
Yep.
Okay? So normally I would put that 7 here. So what times 7 gives me 21?
3.
So 4 times 3 is? So plus 12. Okay?
Do you not add those? Go ahead and add
And-
those together.
Now you could. It would be okay if you did. I'm just trying to be thorough for your notes. And then this one doesn't need multiplied times anything, so neither does this. But here's where you have to be super careful. This negative goes with both of these. So I'm going to write it like this to be thorough for your notes, parentheses x plus 1. Which means 7 plus 12 minus x minus 1 over 21.
Wait a minute. Why'd you do the parentheses x plus 1? Why is it?
Because this negative right here
Yep.
goes with all of this, not just the x.
Okay.
Okay? So if you leave off the parentheses, most people forget to distribute the negative to this right here.
Oh, okay.
So by having this in your notes, I'm hoping to kind of reiterate when you look back,
I got you.
and then I distributed that. Okay? So what's 7 plus 12?
19.
19 minus 1. So I end up with 18 minus x over 21. And that's all you can do.
That's pretty easy.
Yeah, not bad. Okay?
You get out.
All right, number 9. Number 9, I'm still adding fractions, right? Multiply them together to get my common denominator. Do you want to write 2 fractions separately, or you want to skip that step and go right to 1 fraction?
Right to one.
Right to 1 fraction, okay? So I'm going right to 1 fraction. Common denominator is x minus 4 times x plus 3. Okay. Well, what do I need to multiply this x minus 4 times to get the common denominator? X plus 3?
Yeah.
So that means I got to take this whole quantity times an x plus 3. So that's going to look like this. X plus 5 times x plus 3 minus, what do I need to multiply this times?
X over x minus 1.
Okay, so I got to take this times x minus 4. So that x minus 2 needs to be multiplied times an x plus or x minus 4. Once again, you can see those are just cross products.
Yep.
These two are these two multiplied together, and these two are these two. Now, the minus sign is very important here. Those are in parentheses, so this is going to be minus the result of all this. So that means I'll change the signs on all that. So, that being said, let me shrink that down just a little bit. Okay, so if I start multiplying this out, x squared, 3x, 5x, and 15. There's 4 terms. It's like doing it in a box.
Yep.
You can use a box, double distribute, or FOIL, whatever makes sense to you. So I have an x squared. I'll have a 5x and a 3x, which will give me an 8x, and then a 15. minus, and I'm going to put a parentheses because I want to make sure I change the signs on everything. So now I do x times x.
X squared.
Yep. Minus 4 and minus 2 will give me minus 6. Negative 2 times negative 4 will give me a positive 8. And all that's over the common denominator, which doesn't have to be multiplied out. Okay, so now this negative needs to be distributed to all this, right?
Flip the sign.
So yeah, that's going to change the signs, and so I'm not going to change them there. I'm going to write it right above it. So up here I'm going to put negative x squared, positive 6x, and negative 8. So now what cancels? I have an x squared and a negative x squared, an 8x and a 6x, a 15 and a negative 8.
Okay, so you're gonna have
The x, it's not, do you want to draw all together or just what cancels?
Do like 2x plus 7.
Well, I just want to know the result of that whole numerator.
X squared.
X squareds cancel, right?
I'll do that.
Then what's 8x plus 6x? So I get a 14x, and then I have a 15 minus 8.
Plus
15x plus 7.
Yep. Over your common denominator. And that's your answer.
I hope the people watching this video are as skilled as us. They're gonna be lost.
Well, it's going to be Peyton.
I doubt she'll watch it.
All right, so 14x plus 7. Some people might choose to factor a 7 out of there, thinking that they end up with something that would cancel, but you won't. If you factor a 7 out, you'll get a 2x plus 1. And it's okay if you type it in like that, but nothing will cancel. So either one of those are acceptable answers. And you could even multiply the denominator together. That should be acceptable as well. Okay? So several different ways that answer. I would write it like this because it's the easiest way to write it. But yes, you could have an x squared minus x minus 12 on the bottom. Okay? Everybody okay with number 9?
Yep.
Okay. Number 10. Let's see where that lands us. So on number 10, we're going to need a common denominator. And so before I ever start this problem, I would probably factor this in hopes that it factors down to these two.
Oh, yeah, it does.
It does. Good. So this is really the same as y minus 1 times y plus 4. Right? So that makes my excluded values easy. They will be 1 and negative 4. Agree?
Yep.
So what's my common denominator?
Y minus 1, y plus 1.
Yeah, right there. These are both contained within this one.
So I have one fraction.
So let's write that all three of those as one great big fraction. Rather than writing it as 3 separate and then writing it as 1, we'll just skip that middle step. So what do I need to take? This times.
Y plus 4.
Yeah, remember you can pretty much just cross product these.
Yeah.
So y plus 6 times y plus 4 minus y minus 5 times y minus 1. And then at the very end, I don't have to multiply this thing times anything. It stays the same, so will this 4 on the end. Okay, so a lot of simplifying to do there. I got to work this one out. I got to work this one out and change the signs, and then I got that 4 on the end. Okay, so first one,
I squared.
6y and 4y. And then 6 times 4. Okay. Minus sign with a parenthesis, so I don't forget to change my signs.
Y squared.
Mm-hmm. Minus 5 and minus 1 is minus 6. And a plus 5. And a minus 4 in the end, all over my common denominator, which I could just put parentheses to show it's still there. Okay, so now if I change my signs, which you may want to just change your signs right here within this. If I do, I'm going to get a negative y squared a positive 6y, and a negative 5 instead of that.
Go.
So now when I go to put it together, my y squared and my negative y squared
Cancel.
cancel. Then I have 10y and 6y, so 16y. Then I have 24, negative 5, and negative 4. So basically 24 minus 9. So plus 15 all over my common denominator, which is y minus 1 times y plus 4. And that's all there is to it.